Alright, so this video is going to be part 4 of our sequences and series review. Okay, this video will be on ratio of integers. This, I definitely feel like it's going to be like more of a sneak attack question, alright, on a test or something like that, because it's definitely not the first thing that people think of to study. It's only covered briefly. So yeah, anyways, we want to express 2.3 repeating as a ratio of integers. Now, what this means, right, expressed as a ratio of integers, we're just talking about a fraction here. Okay, we're trying to put 2.3 repeating into a fraction. Now, how we do that is first by putting this number into an infinite geometric series. Okay, making it an infinite geometric series, which takes on the form the sum from n equals 1 to infinity of a sub 1 times r to the n minus 1 power. Okay, now what does a geometric series actually look like? Well, for a geometric series really uses this r and this a sub 1. Okay, you start off with the first term in your series being your a sub 1. Okay, let's say that it was 1. Okay, what about, well, how do you get your second term in your series? Well, you multiply this a sub 1, okay, by your common ratio. So let's say our common ratio is 10. Well, then we're going to multiply this first term by 10 to get it. So there you go. 10 is our second term. Now what about our third term? We multiply by 10 again to get 100. And then our fourth term will be 1,000, and so on. All right, so that is what a geometric series looks like. So what we're going to do is make each repeating number a term. Okay, so if you had something like 2.576 repeating, and your 576 is repeating, so it looks something like 2.576, 576, 576, and so on, then this 1576 piece is going to be a term. This next 576 piece is going to be a term. Let me show you what I'm talking about. Now, first off, this 3 is repeating, but this 2 is not. Okay, so we're going to have this 2 out front here. Now this 3, this is just the 3, okay? It's not like a 576, it's not multiple different numbers together that are all repeating. So what we're going to do is we're going to look at the tens place now. That's going to be a 3, okay? And what's another way we can write that? Let's write it as a fraction. Well, 3/10 is another way to say that, and 3/10 is just that. Okay, so what do we have now? Well, what did we just make? Now we have a 2.3. Okay, well, let's keep going. What about if we want to add another 3? We want to add another 3 here. Well, that's going to be 3/100ths, okay? And that is 3 over 100. What about if we want to add another 3? Well, as you probably guessed, that's going to be 3 over 1,000. Okay, and now you see we have a 2.33333. It's going to be all, repeating. So now we see this here, okay, and we can represent this in our actual summation. Okay, and we're going to write that as the sum from n equals 1 to infinity of, remember what this is supposed to look like. It's supposed to be a times r to the n minus 1. Now a, okay, or a sub 1, you might see it as either or. That's our first term. Now our first term is not going to be 2. Okay, our 2 is going to come out front here because it's not part of this geometric series. Okay, you see that we have to multiply by 1/10 to get to the next term, but this 2 does not follow that. So we're going to have a 2 plus out here, and well, our first term is going to be 3/10. That'll be our a. Now what about our r? Like I said, we're multiplying by 1/10 to get from one term to the next. So that's going to be our r. Okay, now we need to find the sum of this geometric series. Now, how do we find the sum? Well, the sum of a geometric series is just a over 1 minus r. And remember, that only applies for infinite geometric series. Now, let's just apply that here, okay? We have a 2 plus. Remember, don't forget anything that does not follow your geometric series. because you don't want to just find the sum of your geometric series. You want to find the sum of your geometric series when added to the rest of whatever you have to add it to. So we're going to have a 2 plus, what's our a? Our a is 3/10. We have a 1 minus, well, our r is 1/10. Okay, so this right here is going to be our answer. Now, of course, we have to simplify it first. It's going to be a 2 plus. You're going to get a 3/10 over 9/10. The 10s are going to cancel out, and you're just left with 2 plus 3 over 9, which is 1/3. And we know that 2 plus 1/3 is going to be 7 over 3. And that is 2.3 repeating expressed as a ratio of integers, right? This is a ratio, 7 to 3, right? This is a ratio of integers. 7 is an integer, 3 is an integer, okay? So that's kind of what we're talking about here. So the first step was to express this 2.3 repeating as an infinite geometric series. Once we did that, we put it into a sum formula, and that's how we wrote down our a and our r, okay? And then we found the sum of this geometric series by plugging in a and plugging in r to get our ratio, okay? To get our ratio of integers. And that's basically it, okay? So that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.